You are alive to witness the solar system's greatest storm die. Right now, as you sit here watching this, something the size of Earth is dying quietly, 650 million kilometers away. It has outlived nations, outlived empires, outlived every person who has ever looked up at the night sky. And in your lifetime, it will be gone forever. But this isn't just about a storm, because if something this massive can vanish without warning, then what else? Have we already lost, without even knowing it? Welcome, dear friend, to Universe Secrets Revealed. If you have walked this earth long enough to have seen the world change with your own eyes, then you already understand something younger generations often miss, that nothing, however permanent it may seem, truly stays the same forever. So before we go further, may I ask something of you, as one would ask a trusted elder for a small favor? If this channel has earned even a moment of your curiosity, consider joining our family by pressing that subscribe button. Think of it not as a request from a stranger, but as an invitation to sit with us again next time and uncover another secret the universe has been quietly keeping. And tell us, if you would, from which corner of this world are you watching tonight? We would be honored to know. High above the clouds of Jupiter, something enormous has been spinning for centuries. Scientists call it the Great Red Spot. It is a storm so large that it could swallow the entire Earth with room to spare. And yet, most people who look at pictures of it never stop to ask a simple question: how long has this storm actually been alive? The answer reaches back further than almost anyone expects. In the 1660s, astronomers pointed their early telescopes toward Jupiter and noticed a strange dark marking on its surface. They wrote it down, they studied it. They believed they were looking at something permanent, a fixed feature of the planet itself. That was more than 350 years ago. To put that into perspective, this storm has been raging longer than the United States has existed as a nation. Generations passed. Empires rose and fell. Wars began and ended. And through all of it, the storm continued turning, unaffected by anything happening on the small blue planet watching it from a distance. Grandparents saw drawings of it in old textbooks. Their grandchildren later saw it in stunning detail, captured by NASA's Juno spacecraft as it flew past Jupiter in recent years. For most of human history, this storm felt untouchable, fixed, almost eternal. But eternity, as it turns out, was never part of the plan. Modern observations have revealed something the earlier astronomers could not have known. The Great Red Spot is shrinking. Not suddenly, not dramatically, but steadily, year after year. Measurements taken in the 1800s showed the storm stretching across a width more than 3 times the size of Earth. Today, it is smaller. Its shape has changed too, becoming more rounded, losing the elongated form it once held. Even its color has shifted over time, drifting between deep red, orange, and pale beige. Scientists tracking these changes have reached a striking conclusion. At the current rate of decline, this storm, older than any living person, older than most nations on Earth, could disappear entirely within the next 20 years. This means something remarkable. The very people alive today, reading this now, may be part of the last generation to ever see the Great Red Spot with their own eyes, or through any telescope pointed at the night sky. Their grandchildren may only know it from photographs, the same way today's generation knows extinct animals or lost ancient cities. A storm that outlived centuries of human history is now facing its own ending, and it is happening within a window of time short enough for people alive right now to witness the whole thing unfold. But this raises a deeper, more uncomfortable question. If something this massive, this old, and this well-documented can quietly fade away, what does that say about everything else in the universe that no one is watching closely enough to notice? To understand why this storm has survived for so long, and why its slow death matters so much, it helps to look at what actually keeps it alive. The Great Red Spot is not simply a large cloud drifting across Jupiter's surface. It is a violent high-pressure weather system, technically known as an anticyclone. On Earth, storms like hurricanes form around areas of low pressure, pulling air inward and upward. The Great Red Spot works in the opposite way. It is built around a column of air being forced downward by intense pressure, spinning counterclockwise once every 6 days. Inside this system, wind speeds reach staggering levels. Gusts inside the storm have been measured at close to 640 kilometers per hour. To put that in perspective, the fastest cyclone wind ever recorded on Earth, during Tropical Cyclone Olivia, reached just over 400 kilometers per hour. The Great Red Spot does not simply match Earth's most extreme storms, it surpasses them by a wide margin, and it has been doing so for centuries without pause. What makes this storm even more unusual is what sustains it. Jupiter's atmosphere moves in distinct bands, and near the equator, these bands flow in opposite directions from each other. The Great Red Spot sits trapped between 2 of these opposing currents, almost like a ball caught between 2 conveyor belts moving in different directions. This positioning acts like an engine, continuously feeding energy into the storm and keeping it spinning long after any ordinary weather system would have collapsed. Today, the storm measures roughly 16,000 kilometers wide, still larger than Earth itself, and reaches depths of more than 350 kilometers into Jupiter's atmosphere. These numbers alone explain why the storm has drawn scientific attention for hundreds of years. But they do not explain everything, because history shows that storms like this one are not guaranteed to last, no matter how powerful they seem. In 1665, an astronomer named Cassini observed a similar dark spot on Jupiter and documented it carefully, believing it to be a fixed, permanent feature of the planet. He tracked it for years. Then, without explanation, it disappeared from the historical record. It was not seen again in any confirmed observation until 1831, more than a century and a half later. For a long time, many assumed this gap was simply a matter of poor record-keeping, an oversight caused by limited early telescopes. But many modern researchers now believe something far more significant happened. They believe Cassini's spot and the Great Red Spot observed later were not the same storm at all. Instead, one massive system likely collapsed entirely, and a completely different storm eventually took its place, without anyone at the time realizing a change had occurred. This means an object larger than Earth, powerful enough to be called permanent by a trained astronomer, may have vanished completely, and no one on the planet noticed it happening. There was no warning, no gradual decline recorded, no clear final observation. It was simply there, and then it was gone, lost somewhere in a gap of missing data spanning over 150 years. This is not an isolated case either. In 1989, a similar storm system known as the Great Dark Spot was discovered on Neptune. When scientists returned to observe it again in 1994, expecting to continue their research, they found nothing. The storm had vanished in less than 5 years, taking with it any additional data that could have been collected. These examples reveal an uncomfortable truth. Storms of this scale, storms capable of lasting for centuries, do not always fade slowly enough for humans to track. Sometimes they simply stop existing between one observation and the next, leaving no clear ending, only an empty space where something enormous used to be. This raises a pressing concern for anyone watching Jupiter's storm today. If history has already shown that similar systems can disappear without detection, then the current, carefully documented decline of the Great Red Spot may be a rare exception, not the rule. And that possibility places even greater urgency on paying close attention now, while the storm is still here to observe. Every storm eventually leaves something behind, even after it fades. But what happens when the thing left behind is knowledge itself? Knowledge that cannot be recovered once the storm is gone. This is where the story of the Great Red Spot becomes far more than a tale about weather on a distant planet. For decades, scientists have used the storm as a natural laboratory, one that no human-built experiment could ever replicate. By studying its layered clouds through infrared instruments, researchers uncovered the hidden structure of Jupiter's atmosphere, revealing 3 distinct cloud layers stacked on top of one another. This discovery only became possible because the storm's intense internal turbulence thinned certain sections of cloud cover just enough to allow instruments to see through them. Without an active, powerful storm to study, this layered structure would likely have remained hidden entirely. The value of this research extends far beyond Jupiter. Long-lived, self-sustaining storm systems are extremely rare, and the physics that allow such a system to survive for centuries have direct applications back on Earth. Scientists studying the storm's rotation and its relationship to Jupiter's spin have refined their understanding of a phenomenon known as the Coriolis effect, the same force responsible for shaping weather patterns on our own planet. By observing this effect operating at extreme speed and scale, researchers gained insights that would have been nearly impossible to obtain by studying Earth's much gentler atmosphere alone. These insights are not abstract. They feed directly into a field known as atmospheric blocking research, which examines what happens when large, high-pressure systems become stuck in place instead of moving naturally across a planet's surface. When such blocking occurs on Earth, the results can be severe. Prolonged heat waves, extended cold spells, and disrupted weather patterns that stretch across entire continents. Because scientists can now predict blocking events weeks in advance, governments use this research to issue early heat warnings. Farmers use it to adjust harvest timing, and food security analysts use it to flag regions at risk of crop failure. A single widespread blocking event, left unpredicted, could reduce global food production by several percent in a single year, a loss measured in millions of tons of food. None of this would have been possible without a storm large enough, old enough, and stable enough to be studied so closely for so long. This is what makes its slow decline so significant. The scientific value being extracted from the Great Red Spot right now, during this narrow window before it disappears, may never be replicated again. Once the storm is gone, whatever secrets it has not yet revealed will disappear along with it. And this pattern is not limited to a single storm on a single planet. The same principle applies on a far larger scale to the universe itself. Space is expanding, and that expansion is accelerating, carrying entire galaxies away from view faster than light itself can reach us. Evidence of the universe's earliest moments, including the faint afterglow of the Big Bang, is fading as it stretches and weakens over time. Future observers, positioned much later in cosmic history, will inherit a universe with far less visible evidence of its own origins. In both cases, a single planetary storm and the universe as a whole, the same lesson repeats itself. Some evidence exists only for a limited time. Once that window closes, it does not reopen, and whatever went unrecorded within it is lost permanently, leaving only questions in its place. Every generation believes it is standing on solid, permanent ground. It looks at the mountains, the oceans, the night sky, and assumes these things have always looked this way and always will. But this sense of permanence is largely an illusion created by the shortness of a single human life compared to the vast timelines of geology and space. The continents themselves were once fused together into a single landmass. Given enough time, everything changes, even the things that appear most fixed and eternal. The Great Red Spot represents this lesson in miniature. For centuries, it seemed untouchable, a fixed marking on a massive planet existing far beyond the reach of human influence or human timelines. Yet, current evidence shows it may vanish within the next 2 decades, well within the lifetime of people alive today. This storm's disappearance is not a distant hypothetical event reserved for some far-off future generation. It is unfolding now within a time frame short enough for a single person to witness its beginning, its decline, and potentially its end. This places current observers in an unusual position. They are not merely reading about history after it happened. They are living through a specific, non-repeating window in time, one where a centuries-old phenomenon remains visible, measurable, and still capable of yielding new scientific information. Once that window closes, it does not reopen. There will be no second chance to observe this particular storm at this particular stage of its existence. The implications extend beyond Jupiter alone. Researchers studying the wider universe face the same limitation on a far grander scale. Distant galaxies are moving away at increasing speed, some already receding faster than light can travel toward Earth. Radiation left over from the earliest moments of the universe, the clearest remaining evidence of how everything began, continues to weaken as it stretches across expanding space. Future civilizations, arriving much later in cosmic history, will look up at a sky containing far less evidence than the one visible today. Some of what current scientists can observe and measure right now will simply not exist for those who come after. This raises an important question about responsibility. If certain evidence exists only within a limited window, then those who currently have access to it carry a unique obligation to study it, document it, and preserve whatever understanding can be drawn from it while it remains available. This is not a matter of sentimentality. It is a practical recognition that some scientific opportunities do not repeat themselves, and once lost, cannot be recreated through any future technology, no matter how advanced. History has already shown how easily such moments can slip away unnoticed. A storm on Jupiter, once considered permanent by a 17th century astronomer, disappeared for over 150 years without confirmation, and modern researchers now believe it may have vanished entirely, replaced quietly by another system, without anyone realizing a transition had occurred. A similar storm on Neptune vanished in less than 5 years between 2 scheduled observations. These are not isolated anomalies. They demonstrate a consistent pattern. Significant, well-documented phenomena can disappear within surprisingly short time frames, sometimes faster than institutions are prepared to track them. Understanding this pattern changes how the current moment should be viewed. The period in which people currently exist is not simply another ordinary stretch of time. It is a specific, limited window in which certain evidence, both planetary and cosmic, remains observable before it fades permanently from reach. Recognizing this shifts the priority away from passive awareness and toward active, deliberate observation and documentation while the opportunity still exists. The Great Red Spot may continue turning for a few more years, or it may reach a tipping point sooner than current models predict. Either way, the underlying lesson remains unchanged. Phenomena once assumed to be permanent are in reality temporary, and the evidence they offer is available only for a limited time. The responsibility resting on those observing it now is not to marvel at its size or its age, but to record and understand what can still be learned before this narrow window closes for good.